We are going to have a brief lesson on some descriptive statistics. While there is some overlap with the type of work we have been doing, the purpose of this particular lesson is to prepare you for a potential future course in mathematics or in quantitative reasoning in other subjects as well. This will serve as a brief intro into some descriptive statistics. First thing we need to do is distinguish between two different types of data. We have both quantitative data and qualitative data. Quantitative data is something that's a measurement or a count of some sort. So if we collected the number of siblings each person in class has, that would be a quantitative variable. Because, for example, somebody could have 0 siblings, 1, 2, 3. And for example, somebody that has 2 siblings has half as many as somebody who has 4 siblings. So arithmetic makes sense. Salary among people varies and is quantitative. Average speed on the way to class, that would be quantitative. But there are plenty of things that aren't quantitative, such as of these two, car make and age, which one is qualitative? Meaning it's not a count of any sorts, and arithmetic would make no sense with it. Well, if you think about age, if these are the age of students in a class, this is quantitative, not only because of these numbers, for example, 18 and 21, but you can actually say the 21-year-old is 3 years older than the 18-year-old. So this age would be another example of quantitative data. However, Ford and Toyota, they're not counts or measures. So this is qualitative data. For example, Ford plus Toyota equals Honda. That makes absolutely no sense. So car make is an example of qualitative data. Right? Another example might be eye color or types of trees in the forest. You might be thinking, why would I at all be interested in qualitative measures? Well, in statistics and in research studies across many fields, including the medical field, some important variables to be considered when you're looking for medical treatments are ethnicity, gender. Those are all examples of qualitative data. So this plays a big role in the real world. Now that we've distinguished between quantitative and qualitative data, our objective in this brief lesson on statistics is to be able to describe quantitative data in particular ways and to be able to describe qualitative data in particular ways. Descriptive statistics is all about taking something like this, a big set of data. Well, this isn't terribly big, but imagine if we got the car make of every student at Brookdale. So there were 11,000 data points, perhaps. We need to be able to describe that in a quick, easy, comfortable way for people to read and see. That's what we call descriptive statistics, and that's what we're going to work on next. And we have specific things we need to do with the quantitative values, and we need specific things you should be able to do with the qualitative values. So let's work first with some qualitative data. For us, we want to be able to create a frequency table with qualitative data and a bar graph, which with qualitative data is called a Pareto graph. We're going to create a Pareto graph with respect to that car make data that you saw on the last screen that is now here as well. So first thing we need to do is we're going to create a frequency table. That's what we have over here. And in my table, I've got my car make column, and then I have a frequency column. Lowercase f stands for frequency, and we'll talk about what that means in a moment. In the meantime, let's just write down all the types of cars that you see here in this data set. I'm not going to write in Ferrari because it's not in there. I'm just going to put in the ones that are in there. So for example, we've got Ford, we've got Chevy, we've got Toyota, we've got Hyundai, and we've got Honda. Now again, imagine we were doing this and this data set was much larger than this. This one is a 5x4 data set, so there's 20 total cars in here. Imagine it was 20,000. We really would want to summarize this for people. So one way that people summarize qualitative data is just telling you the frequency with which it shows up. So the word frequency in statistics and mathematics is the same thing as how it's used in real life. It's the number of times it shows up. So for example, Ford's frequency we'd have to go through and count how many Fords there are. There's 1, 2, 3, 4 Fords. So let's pretend this is a class of students. 4 of the students drive Fords. Let's go through and see how many drive Chevys. We've got 1, just one Chevy. How many drive Toyotas? We've got 1 here, 2, 3, 4, 5, 6, 7. How many drive Hyundai? 1, 2, 3. It looks like we have 3 Hyundai. And then how many drive Honda? We've got 1, 2, 3, 4, 5. And then right underneath of this column here, you see this. This symbol right here is the capital Greek letter sigma. It's used in statistics and mathematics to mean something very specific, and it stands for the word sum. And sum, of course, is the result of doing addition. So anytime you see sigma placed up against the frequency f, that means add up the frequencies or find the sum of the frequencies. So we've got to add these numbers up. 4 and 1 is 5, and 5 is 10, and 7 is 17, and 3 is 20. Now there's multiple reasons for doing that, but as of right now, let's just look at it and see if that makes sense. Should we have gotten 20? Since this is a 5 by 4 rectangle, 5 times 4 is 20, we should have gotten 20. So let's say I'd gotten 19 here. Then I know that something is wrong up here and I need to go back through and check. There are other reasons for computing sigma f that you'll see in the future. But already, instead of just having a list of a bunch of names, this is a summary of this data. And again, imagine if this was 20,000 cars. Having this summary would be much, much more helpful than seeing a list of 20,000 car names. Right? So we've created a frequency table for qualitative data. We also want to be able to create a Pareto/bar graph for qualitative data. And I've started here. You've got your horizontal axis and your vertical axis here. Your vertical axis is always going to be the frequency, right? Your frequency f. On your horizontal axis, we're going to have the car make. Right? In this case, car make will be whatever your qualitative variable is. And when we put in this information, we always want to have the bars going from tallest to lowest. So instead of just putting in each of the 5 car names here, I want to put them in from tallest to shortest. So for example, Toyota is the tallest one, so that's the first one I'm going to put here. So just to abbreviate these, I'm going to put in T for Toyota, F for Ford, C for Chevy, we'll do H for Hyundai, and then Honda will do just D. So Toyota had the most, so that's the first one. And then next one is Honda. So we're going to put in the D for Honda there. Then we've got Ford, then Hyundai, then Chevy. So Ford, then Hyundai, then Chevy. And now on our vertical axis, which has frequency, we need to see what our highest frequency is and figure out how we're going to get up to that number. So our highest frequency is 7. So just like everything we've done in class, this vertical axis is quantitative. So that value right there is 0. And we need to get up to 7. So we may as well just count by 1. So 0, 1, 2, 3, 4, 5, 6, 7. If I was going up to 40, I probably would not count by 1s. Maybe I'd count by 5s or something. And now we're simply going to draw in bars that meet the height associated with the frequency. But the key thing with Pareto graphs is the bars don't touch. Bars don't touch. You'll see that is different when you have a histogram. We'll get to that in a little bit. So the Toyota bar should be a height of 7. Of course, if this was on graph paper, it'd be that much easier, but this is good enough. The Honda bar should be of a height 5. The Ford bar should be of height 4. The Hyundai bar should be of height 3. and the Chevy bar should be of height 1. This now is another description of the types of cars driven in this particular class. And what's nice about this is even if you don't understand the numbers a whole lot, you can at least see the Toyota bar is significantly taller than the Chevy bar. So this describes this data in a more friendly way. People like visual graphs. So to recap, with qualitative data, you should be able to create a frequency table, and you should be able to create a Pareto bar graph.